here I wrote my normal equation like normal. So I wrote my AR, my BR2, gives my AR, BR, and I did my oxidation numbers, right? So my first part is pretty easy because my AL0 went to AL3 plus, added 3 electrons. Everybody I saw was doing that very well. My next part, well, this is BR2, all right? That's a diatomic molecule. I'm not going to change that. But over here, it's not a diatomic molecule anymore. It's an ion. That tells me I have 3 BRs. If I was going to write it, I would write it like that. Now, I'm not going to do that now because I don't really need it. But if I did include that, it would come in front. It wouldn't be at the bottom anymore because BR doesn't make a 3. It makes 3 BRs, not BR3. BR3 is BR hooked to BR hooked to BR, where 3 BRs is 3 individual BRs.
Oh, yeah.
Okay? So if I did this, what I'm going to first notice is that I have 2 over here, I have 1. I would have to put a 2 right there. I do have to balance that part. That's where y'all are messing up. That's why I was waiting to do this one. And that means that now, instead of adding 1 electron to this side, how many electrons will I add? 2. So I would add 2 electrons over here. All right? Now, eventually, if I was going to balance this equation, I would multiply to get my electrons to cancel, but we'll do that in a minute.
Why did you add 2?
Because this was a BR2, so I had to multiply this by 2.
So the 3
So now that's really 2 minus. And so notice I'm ignoring the 3 right now. The 3 is not important. But I'm not trying to balance the equation right now. Eventually I would. Okay? Let me ask you this. Which one's oxidation?
The first one.
This is oxidation, this is reduction. Okay? Alright? And down here, the same thing. So in this case, I have AL0 giving you AL3 plus. Okay? So you should have added 3 electrons right here. Right? Here we have O2, 0, giving us O2 minus. So I'm going to have to multiply this by 2 because it's balanced the O's. So really that's 4 minus. So I'm going to add 4 electrons over here.
Wait, hold up.
So you're going to multiply
So your
the
subscript,
coefficient with the...
your subs,
Yeah, if it's not balanced, I'm going to balance it
your
before I do
subscript
my electrons.
pops out front.
Okay? And notice I didn't do things that I fixed those numbers. I only did the things that had to be that way. Like your diatomic molecules. Alright?
Why would, like, after you do the half thing, why wouldn't you put the little numbers on the bottom?
Because I'm not trying to balance the equation yet. I'm just trying to write the half reaction.
So do your subscript always have to pop up to the front, do whatever?
I hate to say that,
Your
yes,
coefficient.
because remember, I'm going step by step.
Yeah.
Eventually, I'm going to go to a big problem, and so what I've done so far is taught you how to do the charges and now how to do the half reactions. I'm going to fix the things you don't understand eventually. We're just not there yet, okay? Yes.
With the second ones, do you always have to put the electrons in the front, or can you put it in?
No, you can put them in the middle. They just have to be on this side of the arrow. It doesn't really
I
matter.
just didn't know.
And
Matter of fact, I think in my paper, that's why I put them in the middle. It's
And
just,
this
I ran out of room.
It's an oxidation and reduction, right?
That's correct. This is oxidation reduction. The way I've written them, all of mine are oxidation first. The way I've written these. All right. Now, I want you to look at page 18. Now is the time where I'm fixing to freak you out.
Oh no.
We don't have much time, so I'm going to go kind of quickly, and you be paying attention. All right? Now, I still don't think I've taught enough for you to be able to do some of that worksheet. What was the 4th worksheet I gave you?
Hard.
What was the letter?
It was A, B, C, D, E.
So G, I think, is really hard.
I don't.
You may not be able to do G because I don't think I'm gonna get far enough.
We did
You should be able to do A, D, and E. They're just bounce equations. F is just writing equations. G is the first one with math on it.
We can do part of D though, right?
Probably. I have to look at it and see. I can't remember. All right, pay attention. So, hey, listen. All right. So I'm going to first this. Print it out freaky. This is important for you to know because when you go back and look at these examples, see how it says for B, it says I2 plus S2O3, and then way up there, there's a 2 minus.
Yeah.
That 2 minus is supposed to go with that behind that O3. And then I plus SO4, and then way up there's a 2 minus again. I don't know why when I changed it to a PDF, it jumped like that.
Or is it
Is
2
that
minus plus 2?
negative supposed to be with the I?
Look, Yes. When you see, guys and girls, so when you see this first line, that first line is written pretty good. But when you look at B, those little things at the top, they go down. Yeah. E did it also. D, you can kind of read it, but for some reason, B and E, those superscripts went way up there. All right. I'm going to have to talk fast. If the bell rings, do not leave until I finish. Because if I try to get halfway through this, it's going to be crazy. I apologize to you seniors. All right. So, the first thing I'm going to do is assign oxidation numbers. Everybody watch. Okay? This is a 2 minus. That means a 6 minus. I need you -1, so this is a 5 plus. That one's already got an oxidation number. This has already got a base. This is by itself, so that's a 0. That's a +1. That's a 2 minus. So, right now, just trust me on those. But the first thing you would have to do is figure out the oxidation numbers.
What was
This I already has a negative charge. See? It's
Not
written
that
in the
one, the other
problem.
one.
This one is a 0.
So that's
Because it's by itself.
positive.
Oh, this one is a 5 plus.
5 plus.
Look. 6 minus. It's got to equal a total of 1 minus.
So
So if
5.
that's 6 minus, it's got to be 5 plus.
Makes sense.
Because 5 plus and 6 minus equal 1 minus. Okay?
It's like squishing
Now,
these together.
I'm going to write my half reactions. This I went from 5 plus to 0. So I'm going to write IO3 minus, I'm going to put a little 5 plus right here, yields I2 0.
How do you know it was the iodine?
Well, because I'm looking for what changed. So 5 plus went to 0. But look, here's another iodine. This is an I minus, went to I0. So look, this one got more negative, this one got more positive.
And for the IO3, how do you know it was the iodine that is a 5 plus?
Because the oxygens stayed at -2, the hydrogen stayed at +1. They didn't change. Stay, okay? All right, so what's going to happen here is now I've got to do my thing that I've been doing. There's 2 I's here, there's only 1 there. I'm going to put a 2 in front of this. That gives me a 10 plus. Right?
Uh-huh.
Everybody agree with that?
Yep.
So that means I'm adding 10 electrons here.
Oh,
Yeah, because that's more positive. I always add to the more positive side. This one's got 2 also. I'm going to put a 2 here. That's a 2 minus. So I'm going to add 2 electrons over here. Everything I've done is stuff that we just have done so far. Here's the new part. When I get ready to balance this, what I have to do is I have to make my electrons equal each other. I can't have electrons just hanging out in the equation. So this equals 10, this equals 2. If I multiply this whole equation by 5, I will get 10 electrons, won't I?
Yep.
Matter of fact, this becomes 10 electrons, this becomes 5 I2s, this becomes 10 I1s. I'm going to mark all this out so you see what I did.
So we're multiplying that whole thing by 5.
I just multiplied that whole equation by 5.
Okay. And that would be 10.
Now, I'm going to combine that. And now I'm going to combine those 2 things. My electrons cancel out. And I'm just going to go in order. That gives me 2 IO3 minuses plus 10 I minuses plus, I'm going to put my hydrogen in there and I'll come back to those in a minute. Plus, look what I got. I got 6 I2s because I have 5 here and 1 there plus H2O. Now, I'm not quite finished,
Oh my goodness.
but I'm almost. Notice that I just stuck my H's and my H2O's in there. They're in there just to make sure my everything balanced out. Look right here. I have 6 O's. Over here I have only 1. I'm going to put a 6 right there. Now I have 12 H's. I'm going to put a 12 right there. That equation is now balanced. Or I can reduce it. I could even reduce it. So I could go IO3 minus plus 5I minus plus 6H plus 3I2 plus 3H2. This is actually more correct.
So you don't have a
So you
chart
can
on
reduce.
what you produced.
I can reduce it. Everything's reducible. Okay. we'll stop there. Instead of trying to do worksheet, what did I say, G? Try to balance some of those equations on number 3. Try to do 2 more, just 2 more, not all of them. Yes.
Okay.
On number 3.
On number 3, where I was on task, that's task 3BI, number 3. There's A, B, C, D, E. Just try to do 2 of them.
One, is this supposed to be an error?
This is very
Oh,
hard.
yeah.
Good luck.
Fix it for me.
You don't have to put charges on these two?
Not after you find your final.
That was my question.
Well, it's gonna be, yeah, it is.